Well, hello, ladies and gentlemen. Today I promised that I would put a little video of me solving these AP1 core problems down. So that's what I'm going to do. If you look at these core problems and you read the first one, up above it, you notice that we have the big five equations. We're only going to use five equations to solve any core problems in here. And for starters, I've got a problem that uses the first equation. So you've got the position at any given time of a particle. So to get the real position, all you have to do is put a time into this function. And it says that we're going to start at 3 seconds. So let's come over here on the left-hand side where I've established that at 3 seconds, we put in to the equation 3 cubed times 4 plus 3. That gives us 111 meters. I come over to my handy-dandy table on the right, and for the sake of time, I have put that we start our problem at 3 seconds, and then we change it according to this table over here. That table says that let's evaluate this particle like we know we start at 3, but where is the particle 0.01 second after 3, 0.1 second after 3, 0.2, 0.5, 1. So I've put the true time in this column, and now I'll put the change of time into this column. There's a reason why, and it's coming up. Because we learned from graphing and we've learned from our reading that the average velocity is a final position minus an initial position over time. Well, look, this one, the bottom one, you can't even do a change in time because 3 doesn't change from itself. So we can't even find a velocity. But what we can do is we can apply this equation right here, and I'll write it out long once. The final position in this interval is 112. The particle started at 111 meters, and the final time period was 3.01 minus an initial of 3 seconds. Okay, we put that into our calculator. 112 minus 111, and we divide from that 3.01 minus 3, and that tells us that we were going 100 meters per second to start off. Well, how are we going to do the next one? Well, I'm not going to. Now, I'll do it a little quicker. So for this one, we've got 122, because that's the final position, minus the initial position, which is minus 111. And then we got to see what the time was. Oh, it was 3.1 minus 3 seconds. So that's pretty easy. 122 minus 111 is 11. And we'll divide that by 0.1. This is 110 meters per second. So now you're starting to see how we're going to solve all of these problems right here. We're going to take the final time period and always compare it back to the original to get our numbers. I'm sorry, I'm writing on my smartboard in class if you're wondering why it looks so funky. I just think it's a little bit easier for you. That's 3.5 minus that. And then this one here would be 259. So I just showed you how to solve all of these. And now, for the sake of saving time, I will go to core problem 2. Let's slide down. You notice that all my stuff stayed with me here. So I'm going to do some erasing. Core problem 2 involves something that is falling from a building. It says calculate the amount of time it takes the ball to hit the ground. Well, what do we know about this to begin with? Well, we know that gravity equals negative 9.8 meters per second squared, because everything that falls has to deal with that. We know the height is 20 meters. And you know what else we know about the ball right here? Its initial velocity equals 0 meters per second. And we don't know the final velocity. That's still kind of an unknown, right? But we know the initial velocity equals 0 meters per second. So it says calculate the amount of time for the ball to hit the ground. Well, all right. So how can we calculate the amount of time? That's what we're looking for? Well, why don't we use the acceleration equation? Acceleration equals VF. Oh, we can't use it because there's two unknowns. Oh, no. But there is an equation we can use to solve for this. We can use any distance in the y equals an initial velocity multiplied by time plus 1/2 gt squared. Hey, you said there's no initial velocity. Okay, so that equals 0. So y equals 0.5 times 9.8 negative. Okay, and then we'll do t squared. Well, there we go. We just put that in the calculator and we can solve it out. How about the velocity of the ball, the exact moment it hits the ground? Well, our knowns haven't changed. 9.8, y equals 20, initial velocity equals 0, final velocity equals question mark. Oh, you know what? We don't even need the height. We could use the acceleration equation. Final velocity minus initial velocity over time. And then we can acknowledge that this A is a very special acceleration. Final velocity, well, that's our unknown. Our initial velocity is 0 meters per second. And then we can use the time from up here. Whatever time we get up here, we're going to drag it down into that one. There, that's a simple, quick way to solve these out. I hope you enjoyed it, because that's all the longer it is.